So reverse osmosis is the idea of removing metals or molecular weight from water. And they use it under high pressure, and you pass it through this special membrane that rejects Dalton weight. And a Dalton weight can be molecular weight. And if you think of it in a filter, but it's not a filter, there's a lot of chemistry that goes behind this. But if you think of it like a filter, it's got a micron size, and it rejects ions. It rejects molecular weights. So if you look at the composition of water, everybody says and everybody knows water is H2O. Well, what does that actually mean? Is H2O coming out of your tap that you drink? No, in that water, water is a solvent. It doesn't like to be pure. So it strips elements and it strips minerals from its surroundings. So in water, you'll hear hardness and softness and loads of different types of things. All reverse osmosis does is it rejects these heavy weights, heavy molecular weight molecules, and it only allows, or it wants to only allow, H2O through. There's other things that can pass through, that have lower molecular weights. But if we talk about reverse osmosis, purifying water, in its simplest, we think of it like a filter. But it's definitely not a filter, but we can think of it like a filter. So it's rejecting hardness. It's rejecting chloride. It's rejecting bacteria, microorganisms, total organic carbons. It's rejecting all of these things, and it's allowing only H2O or under a certain molecular or Dalton weight ion through this very specialized membrane. And at the end of it, we collect something that we call permeate, because it's permeated through the membrane, and we've got a treated water stream. Everything else that's rejected is now a concentrated of these ions, and that goes down to drain. So in its very simplest form, if we think of it like a filter, we put dirty water in, we get permeating through the membrane, we get this nice clean water coming out, and we get a concentrated of all these unwanted ions going down the drain. Reverse osmosis.